Boa tarde a todos, mais uma vez. Espero que se encontrem bem e sejam bem-vindos a mais um webinar de uma tarde técnica da EFRIARC, este com o nome de Pressurização e desgaseificação de sistemas hidráulicos. Irão ver durante este webinar que, de facto, estes componentes que fazem parte de sistemas hidráulicos de climatização são muito importantes para o bom funcionamento do sistema, para o prolongamento de vida dos componentes e também para uma maior eficiência dos seus equipamentos. Eu quero aproveitar agora também para vos informar que a EFRIARC está com muitas ações e debates sobre sistemas de climatização neste contexto agora que é de pandemia. Portanto, estamos com debates, com pareceres técnicos sobre sistema de climatização em edifícios, digamos, considerados de serviço vulgares, como escritórios, mas também com grupos de trabalho dedicados só a sistemas de climatização em hospitais. Por isso, eu, digamos, apelava para que os vogais da EFRIARC que aqui estão presentes, para os associados da EFRIARC que aqui estão presentes, pudessem nos acompanhar e colaborar nestas ações e debates técnicas. E para quem não é membro da EFRIARC, acho que é uma ótima oportunidade para se inscrever na EFRIARC, porque poderá usufruir e poderá dar seu contributo neste contexto agora que é de pandemia, que eu penso que será muito útil nos próximos meses, em que todos nós vamos mais uma vez estar dentro de edifícios onde a abertura de janelas poderá ser um pouco mais difícil devido ao clima mais austero. Mais uma vez, obrigada. Passo então, já agora também agradeço ao Bart De Wandeler o facto de ter aceito participar neste webinar, assim como ao engenheiro António Miranda, também da Reflex, por ser tão solícito. E passo então a palavra agora ao engenheiro Luís Neto, vice-presidente da EFRIARC. Uma boa tarde e continuem bem.
Boa tarde a todos mais uma vez. Hoje temos este webinar já divulgado e que contamos que seja do vosso agrado. Pressurização e desgaseificação de sistemas hidráulicos. O nosso orador é o Mr. Bart De Wandeler, da Reflex Thinking Solutions, e durante a próxima hora, sensivelmente hora e um quarto, vamos ouvir falar sobre este sistema tão importante. Gostaria de dar as boas-vindas ao Mr. Bart De Wandeler, já lhes dei antes, em inglês, obviamente, e queria chamar a atenção que este webinar é possível devido aos nossos membros beneméritos. A Reflex é também membro benemérito da EFRIARC, mas não é a única, e, portanto, tudo isto apenas é válido graças a este esforço dos nossos membros beneméritos. Algumas informações adicionais. Durante o webinar, possivelmente surgirão algumas questões que gostariam de ver resolvidas e têm duas maneiras. Ou através do bate-papo, a ferramenta própria do Zoom, em que podem tentar fazer perguntas, quer em público, quer em privado, para mim, ao nosso orador. Outra maneira de participarem é enviando diretamente e-mails em inglês para o Bart ou para o engenheiro António Miranda em português. E, portanto, sintam-se à vontade para fazer de uma maneira ou de outra. Se no fim desta sessão houver tempo, as questões podem ser traduzidas para o nosso orador, de forma a que eu possa tentar responder online. Para evitar as questões que depois repetidamente se põem, vou só relembrar que todos aqueles que solicitaram certificados de participação serão enviados para os e-mails com que se registaram, assim como a apresentação dos slides em PDF, isso está garantido, e posteriormente daremos acesso à gravação deste webinar em vídeo para que possam rever ou ouvir novamente as palavras de todos que foram dadas. E, portanto, mais nada havendo a dizer, vou passar a palavra ao Bart. So, Bart, welcome again.
Thank you.
And let's try to show us what's happening in this kind of systems, okay?
Thank you. I will share my presentation now.
Okay.
Is it on board?
Yes.
Is it okay?
Yes.
The sound is also okay?
Yes, you can go.
Okay, thank you. Hello, good evening, everybody. Welcome. We will start the presentation about pressurization units and degassing units. This will be slightly like 40-45 minutes that I will go through some topics that are important for an installation and also show a little bit what kind of products we have to cover all those solutions and what is actually the behavior of those products in an installation. Today, we have in Reflex actually 3 big topics about products. As you can see, we have with commercial equipment. This is especially degassing systems, it's expansion tanks, and it's also manifolds. Also for the smaller buildings, residential, we have of course the static vessels, also boilers and degas systems. I will speak also about this. And for the industrial or bigger systems, we also share of course the bigger pump systems and also the gas systems that we build on demand of the customer. So we are active actually in those 3 big parts in the Reflex company. Today also everything has to go quite fast and quite quick. Installers have often, designers have often also not a lot of time to make the job to a good end. So Reflex takes also the focus to make sure that every compound that we design is made for an easy install. So this has a big performance. You will also see that in our pressurization units. You will also see that in our degassing units. You, for example, will also see that we make a design with interfaces that are all similar so that it's easy for the installer, easy for the designer to go and work on site with that kind of tools. So this easy install is for Reflex and certainly for our R&D, a big advance to achieve, of course, the perfect installation for the client. I will start a little bit with pressure maintenance. Pressure maintenance is today more important than it was before. Why? Because systems, of course, are getting more complex than it was usual. We are going to mix heating with cooling. We have heating panels, we have radiators, we have floor heating, we have floor cooling. So it's getting quite tricky to find a good balance in your system. A pressurization unit, or let's start with the static vessel, has so a very important role in the behavior of a system. And also after commissioning, the system has to run smoothable and not with the intention to say to the installer that he has every month or every week has to go back to his system to look what is happening or to see what the problems are. So I will start a little bit with the pressure maintenance. Today, if we look to a pressure system, we have some definitions that you also can find on your own manometer in a system, of course. quite easy. This is not high technology, not high, very difficult. It is easy to understand. We always start at the manometer, for example, with the static pressure. The static pressure, this is normally the height of your building. Let's say that we work here in this example with 20 meters. That means that we need 2 bar in the system. The P0, this is the really setting of your expansion tank. This will be always a value, in this case, 20 meter divided by 10 is 2 bar, and we add at least 0.2 more 0.3 bar to achieve the P0 of your expansion tank. This is the start of your system. After that, you also have to be sure, we have here a program now of 2.2 bar, that your filling pressure really is a pressure that achieve at least plus 0.3 bar above your P0. If you don't do this, you will never have also, for example, in a static expansion vessel, your water reserve. And if you have no water reserve, that can have the result of collective damage in your system, and it can go very fast. So that filling pressure is very important when you start to fill your system, and it has to be always higher than your P0. That means 0.3 bar. So here we will fill the system, for example, at least with 2.4, 2.5 bar. This is the value that you need to see on your manometer. This is very important. If you don't do this, we don't have in our expansion tank a start with the water reserve in cold position in cold start. What is also important, this is the end pressure. The end pressure can be calculated. We have also programs that I can do it for the installer and for the engineer. And the P-end, this is actually in the most extreme condition. That means in the most hot condition of your system, for example, 70 degrees. This is the maximum value where your manometer can stop. And this is the rest of your manometer. Actually, the relief pressure is the safety margin guide. For systems below 5 bar, that is a European norm, we will work with this value here around, no, it's not around, exactly 0.5 bar. So this is a margin that we always calculate for the static vessel. I also have made a small text here on the right side, but again, a small presentation of what this manometer or what those pressures are really doing into a system. And you also see if the pressure here is higher than the PE, you are always going to enter the zone where you can relieve or open your safety valve. But the mention of a safety valve is to protect, of course, a closed cooling or heating system. But this thing should never go open, never. This is a condition that we have to use to be safe and to be conform in a system. But this is also a valve that we cannot see go open in a startup or, let's say, a running phase of a system. Often, we see, of course, other things in an installation, but this is related because this whole cycle here is wrong calculated. I go to the next slide now. So for the pressure static vessels, of course, Reflex has 3 ranges, 3 big ranges. We have the vessels for cooling and for heating and also for solar systems. We have systems for potable water, and we have also systems for non-potable water that can be used for pressure boost systems and also for other things. So these are the 3 main systems that we provide in static expansion tanks. The difference actually between the 2 ranges that we have we have, or we can provide systems with membrane, where above you have always your filled air, your nitrogen or air that is in the vessel, and below you have always your water and of course your water contents of your system. Here you also can see the water is always in contact, of course, with the metal of the system, or let's say with the metal of the expansion tank. If we work with the bladder, your medium is a little bit better protected. Why? Because the water will always be inside into a bladder. So that means that there is also no contact with the water against the metal of the vessel. So those two are the big main difference between diaphragm and a bladder vessel in the reflex range. But of course, they can always be used both as well for heating, as well for cooling. The big advantage that we also have with bigger bladder vessels, when you have a vessel, for example, of continents of 2,000, 3,000, 10,000 liter, if there is a problem with the bladder, an installer is always able, also with smaller vessels, of course, to replace a bladder, and then you can restart also the working principle of the expansion tank. This is, for example, a small indication of a customized vessel for water storage, where we use actually special vessels with big DN flanges connected, and also with bladders inside that are installed for water transport. This is of course not a closed loop, this is an open loop. This is to maintain the pressure drops that the heavy pumps can create. But this is also something that we use in smaller systems, in boiler house systems, in apartments where we have drinking water, but then in smaller solutions. If I go then actually to another kind of range of reflex systems, as you maybe already know, we can provide also systems that are completely self-controlled and will maintain the pressure in a closed loop for heating or solar with a compressor or a pump system. This here, what I point out here, that will be also our Servitech that will maintain the degassing. I will explain that a little bit later. I will first start with the systems with compressor and the system with pumps. We can also provide manifolds on demand to provide also into your system. We can also provide the separators to devise temperatures in your system, or to bypass if you have no heating consumption. And we of course have also air and dirt separators. Air separators always above the system, and the dirt separators always on the backflow. If we see today what is actually the advantage that we have if we use, for example, a pump or a pressurization system with compressor, that we first of all can reduce a lot of space and reduce a lot of expansion vessels, because a static vessel is completely different calculated. It's always a good, healthy static vessel may contain actually at least maximum 1/3 water capacity, and 2/3 of the vessel is actually only air. So when we go to look to a little bit more the bigger system, this providing of 8 or 10 or big static vessels is not so common anymore. Also because it is really difficult to maintain here a perfect stabilization of your P0. Because this is not a science, it's quite easy. The vessel here can, for example, have a P0 of 2 bar, but this one can have a P0 of 0.9 bar. There will be always a small difference. And this will also mean that this vessel has the risk to get full wet water and break. And this vessel, of course, due to the fact of a little bit higher P0, it will never work. But that also means that the complete continence of the water reserve is actually not full fitted for your installation. So those are really quite critical points also for afterwards to look after degassing and corrosion, and also heat transfer. The consumption of your heat or cooling machine is all related to the setup of a water reserve in an expansion tank. So this is today at least more important than before. So we can reduce all those vessels with 1 or 2 or also maybe 3 controlled expansion vessel systems. The advantage that we have, of course, like here with the compressor system, is that we are going to work fully automatic. That also means that an installer actually don't have to re-enter the site or his building to check if the P0 of the expansion tank is still okay, if the water reserve is still okay, or maybe the guy that is responsible in an apartment and every day have to make his own filling water below because some people have removed air in the radiators and so on and so on. That can make a complete unstabilized system. So this is one of the big advantages when we are going to start and use those automatic systems. Of course, there is also an easy alarm setting, so the installer can see if it's possible from a distance. That can be with a remote control to his iPhone, to an iPad, to an Android phone, but it can also go to a GPS system in the building. So it's also a very easy setup, and we can provide the most standard common Ethernet connections about alarm settings. That means like Profibus, Modbus, Ethernet, BACnet, those things are all available in the Reflex systems. If we look to a compressor system, it's a small setup. We also can show that, of course, in the training center where installers can get trainings from Reflex, but I will show it here a little bit similar, but not with the hands, not in practical, it's only theoretical. Of course, we have the expansion vessel. We always have a bladder inside. This is a closed vessel. In a compressor system, we always have a complete closed vessel. That can be a vessel certificate for 6 bar, or that can also be a vessel, for example, certificate for maximum 10 bar. But this is the max that we can provide. We can go higher, but this is not standard and it's not so common. It's also more expensive then. We have, of course, the water area in the system. We have here the control unit that will be always the same interface for every unit that you use. If you work with a degasser, if you work with a compressor system, or if you work with a pump system, we will always use the same friendly interface, what makes also the life for the installer easy, because he will always have the same machine in the front of him. So the programming is also quite easy to install. This is also a critical or an important part, of course, below the vessel. This is the pressure unit or the pressure load cell that will make sure that we know how many water there is in the vessel. For example, when we achieve the maximum water level as a critical, or when we have done a degassing and we don't have enough water reserve here in the water, this load cell will activate all settings and alarms to make sure that your system can provide extra water reserve. what is very important, of course, for a closed loop. This is also meaning that nobody has to enter the boiling room to do, for example, a manual water filling. And the problem is also with the manual water filling, you don't have a clue. You can only look a little bit to your manometer, but you have no clue how many water there is actually needed and how far you can go. Certainly, when you are working with a static vessel. Of course, there are some other parts. We have also here the safety valve. This is only for design and for the inspection. We have, of course, the compressor. We can also provide systems with 2 compressors. And we can also, for example, provide an extra unit with an extra compressor that we put or in master slave, or that we put in a redundant system. What is the big advantage for that? If it would happen that one system here goes down due to the fact of a technical problem, you will always have a second system that can control. Of course, with the second vessel, the second load cell can control perfectly the maintenance of your system. So all those extra options are also available, and to provide your customer a good solution. We also have some small parts like the magnetic valve, the pressure sensor, and of course the flexible connection. This connection will be connected to the return of your system. And as you can see, those systems are also not very complex. We try to use as less as possible equipment to make sure that it is easy and that we don't have a risk to have components that could go out or go in error, and that we have an unstabilized system. So this is also the R&D and Reflex that makes sure that we always keep it very simple. The only thing that the installer has to do is make sure that you have provide, of course, your power supply, and you have to do a calibration. These are 4 or 5 steps, and this system can fully run automatically and do the pressure. I will start here a small movie. This goes quite fast, so I will try to do it, and otherwise I will repeat it. So we start the boiler, the system is running, and we get a higher pressure. Then we will relieve air in the compressor system, and of course the water that's above the pressure will enter the vessel. And then you see the manometer is stabilized. When we get colder water, of course this will go down, and then we start the compressor, and the water will put really directly back to the system. And when the pump is running, and also the pressure is again stabilized. So this is a quite simple, but it's of course is very useful. For example, if somebody degas above in an apartment a radiator, you will see that the control of it is really nice, because when we scroll down now, you will see that the pressure is relieving because we make space, we relieve air. So what will happen is that because we have done a small degassing above, the system will detect this and will put automatically water back to make sure that above we have no negative points in the system. Also, when the volume is getting critical, we open a water makeup and we will start to fill to make sure that the water reserve in your expansion tank is always perfect controlled. So you don't have to make any movement about filling with hands, or it's all automatically done. This movie goes a little bit fast. I don't know if I have to repeat it. And otherwise I go on, and if there are questions, I always can go back after the presentation to start it again. If we look to other systems, we can also provide systems with pumps. It's a similar procedure, except that we also have some options for a kind of degassing. It's not a degassing like we do with the Servitec systems. We go not so deep. It's more related to an atmospheric pressure. Those systems are also full automatic. It's also related to space saving. Why? Because we also need smaller vessels. The system is also regarding pressure, stabilize the pressure between 0.2 bar. The compressor do it in 0.1 bar, but then the systems of the pump, we take a little bit higher range because otherwise the pumps would bending too much and go in on off. We also have here included automatic water makeup. So he will provide automatic the water reserve and the expansion tank. We have a kind of automatic air separation. I will explain it a little bit. And of course, it's also quite easy to install. It's not so difficult. If we look to the pump systems, again, we have, of course, in the pump systems, we are working with an open tank. It's a tank that is atmospheric connected with that atmospheric pressure. So this is 0.9 bar, not more. We have also a quick relief air vent. This will make sure that if we degas, that the gas bubbles again go out. And of course, we cannot re-enter air because it's a one-way direction. We have, of course, also the pressure sensor to maintain. We have the flexible connections to connect. You have to do this on site. You will receive a vessel and a unit. You have to connect them. We have, of course, the control units. We have pumps with soft start, so they are also not aggressive. If we start the Variomod system, it will be not go to full power. The pump will start smoothly, so that will be also making a kind of safety for your system that you don't get very hard, heavy shocks in your closed system when you have a pressure drop, for example. And we also have the control motor valve. This is from Bilimo, where we can switch and also arrange a little bit the degassing, and we can also switch to enter water or to pull or push out water. And of course, like in the compressor system, we also have the level measurement that we can see the level status of the vessel here on the screen, or you can send those values also to a BMS system, to an alarm system, to protect and to look from a distance. So this is also the area where you can provide, or where the water is inside. And we also use a butyl bladder, because a butyl is a bladder that has a better substance against diffusion. If I see, I will start also a USB for the compressor, for the pump system, sorry. So we will start the boiler will run. We are heating up the system will go higher in pressure, of course. We will send this value to our control units, and we will relieve the valve. We will open the valve, and of course, we will stabilize the pressure. We will take in the water, we degas also, and we will stabilize also the pressure. If the pressure goes down, then it means that we have to do the average, that we have to do actually pumping water back from the expansion tank to the system with the pump to again stabilize the pressure in the system. This is the third stage. What we also can do when the system is heating, is running, we have the free air bubbles that are running and pending into the floor heating, cooling panels, whatever, or even the radiators above on the top, the highest equipment that is installed in your system. What we are going to do, we start the system, this is full automatic, and we will degas. We will pump water into the vessel, and we go around to the system, and we will remove air. Big air bubbles will be removed. Of course, we will also get water drops because we remove air and we make place for water. So that also means that we then have to start a protection to make sure that this water reserve in the system is still available. We can open a valve and we can also put water back into the system. If the pressure goes down and we have less water, this is the next step. This valve will go open and city water can go back into the vessel. This is what we are doing now is the degassing cycle and stabilize constantly the pressure in the system. Of course, when we degas, like I have mentioned, we can go to a critical water reserve. This is dangerous. This is the problem that we have often with static vessels. We degas and we have not enough water reserve. We get an alarm. We will open the water makeup line and we will provide again the suitable water reserve for the pressurization system. If we look today to systems, of course, a bad or wrong pressure and degassing is very important. If we look to all the damage and to all the heat loss that we have and all the problems that people have in buildings, in offices, to get a good heating radiator of the cooling that is not working efficient, and also due to the fact that we don't have a good pressurization system that can lead to a lot of damage, for example, cavitation of pumps. This is really actually bubbles air that are exploding in the pump inside. You can also create, if you have a wrong and bad pressure maintenance, you can also create very heavy negative pressures in your system. Of course, one of the most important topics is when the pressure and even your degassing is not controlled and not efficient, you will get a lot of heat loss in your equipment. This is for sure. And also, if you see like here, the zone that is completely blue, that means also that we will start a quite heavy reaction on corrosion. And of course, this is related because energy today is not so cheap. It's related that we pull out a lot of money out of the door. This is also an example of a pump with heavy cavitation. So that also means that a pump that has cavitation or that has small, like here, small cavitation damage, this pump has also not anymore the full power. That means also that your pump needs more consumption, more electricity. And this is also a negative effect on the circulation of your system. If we look to the products for Reflex, of course, we have residential equipment. Of course, with, for example, here, a small degasser system. We have a static expansion vessel. What is this small degassing system is also able to do is to protect the pressure in your closed heating or cooling loop with a static vessel. And if we have a big pressure drop, the Servitech can also maintain that pressure drop, and it can also make sure that we have a small water makeup so that the water reserve in your static vessel is also protected. We also, of course, provide the manifolds for systems, and also a big part of the Reflex is, of course, the water quality. The water quality today is also quite important because we are working with small boilers, with small pumps, with small heat exchangers. And the advantage is, of course, also that we don't have to add any chemicals to a closed water system. This is the same for bigger, let's say, apartments, offices, buildings, airports, bigger installations. We also provide boilers, the potable water, the heat exchangers, the complete setup manifolds, the expansion tanks, the pump systems, and also, for example, boilers that are connected with solar panels and external providers for heating water and stock, and also, of course, the static vessels. And we also do that for industrial, for bigger applications. We can provide customized, complete skids designed by our departments and, of course, delivered in several ways. This is an example where you see expansion tanks with a big degasser system. This is for a district, this is for a power consumption factory, but also here, two big, let's call it variomat pivas. But here, of course, you see no control box because we all have programmed it with the Siemens S7 as required from the customer. We also, for example, here have no load cells. We have here high temperatures, so we have other safety equipment to connect to the Siemens to provide and to control the water level. This is with maximum here and minimum providers that are connected with the expansion tanks. And the customer has also in glass a visual output of the water volume in his tanks, as you can see here. So those applications we are also able to build. This is also to show that the performance, the R&D, and the thinking behind our products are even achieving high demand customers. That it also means that we actually make copy of those kind of solutions to normal standard equipment of Reflex, and that we can provide also for the installer, for smaller systems, a perfect layout and working system. This is, for example, like I have told, we provide also often, this is for district heating. This is 2 times a variomat system or gigamat, it's bigger of course, with 4 pumps, and we work complete and redundant. So we have actually 2 control boxes. Of course, those control boxes are made on demand because we have higher power, we have higher demand of heating. Everything is provided on the skids, everything is welded. This is what the customer gets. The only thing that the customer has to do is provide his piping from his system. In this case, it was actually only 1 pipe because we have a cool down vessel. And so the installer has also an easy install. And this is the big task and the big thing that Reflex also can provide. The next point that we go to see now is a little bit of degassing technology. In my almost more than 10-year experiences, I see even today that degassing of a system, if it's now a small building of heavy industry, it is getting very important. And it was already important, but we see also that it's getting more and more important. The concept, I could speak hours about it. It's also not a quite easy material to explain or to understand, but the way that Reflex has designed his degas system is all related to Henry's law. And actually, Henry's law is, like I mentioned here, is describing actually the behavior of gases and liquids in a water, in cooling water, in heating water. And actually, what we have done in Reflex, and our degassing systems are also worldwide patent, so they are protected. Actually, this thinking from Henry's law, we have actually made in our design and our working principle of the vacuum spray tube degassing. So let's call it the Servitec. And actually, the solubility of gas in a liquid actually can perfectly be compared with actually the dissolution if you put, for example, salt in water. It's actually the same principle that we are going to achieve. Excuse me. And actually, what does it mean in practice? This means actually this law, this principle tells us that a gas is more easily absorbed into a liquid when it is under pressure. So that means that the system that is closed is always under pressure. If it's now a low pressure or medium pressure or a high pressure, all what is nitrogen, everything what is oxygen is actually kept in the water, related to the pressure, of course. And of course, when we can relieve this pressure, like with the Servitec, with the degassing system of Reflex now, we can achieve this, and we can, of course, erase all those gases, and of course also nitrogen, because nitrogen is also very negative in the closed system loop. If I look to the graph of Henry law, I have made here a part of nitrogen, and I've made a part of oxygen. And if I look first of all to nitrogen, in the system, you can see that if I have, for example, a system with a very low temperature, a cooling system, for example, you see here that we have, for example, in 30 degrees, a cold system, we have already around 90, that means milligram in 1 liter of water. This is quite enough, and that's quite high. It's a quite high amount. If we fill an empty system with cold water, you already see that the amount of nitrogen here is heavy, is quite high. And this is also the same for oxygen. So when you start filling a system, you already put a lot of oxygen, a lot of nitrogen into a closed loop with all negative aspects, of course, after the making and after the startup. And this is also for the water makeup. The automatic water makeup has the same containants of nitrogen and oxygen that can give negative effects on your consumption, on your heat or cooling transfer, or on damage on all different equipment on your installation. And what I also would like to explain, the degassers of Reflex, I have here a small output of this graph. And as you can see, this means actually, this is a German word, I was not able to translate it, but this is actually the cooking point of water. And what we are doing, this is the small graph, what we are doing is actually putting the water back to a negative pressure. That means between 0.5 and -0 bar. And we are actually cooking the water. And then you can see that the nitrogen is, most of the part is gone. And this is also the same for the oxygen. We are working here 2 times in this small area. And this is what the Servitec is doing. And this is then the result that we have. And this is all based, of course, on the law of Henry. So it's not that Reflex have thought about it or that's something that is not true. This is pure physical behavior of a liquid. And this is actually what we are doing in a system with the degas. Degassing, of course, this is necessary, but of course it starts all with the water makeup. You start filling an empty system, a new system, an old system after some repairing. The first thing you do, you use potable water that potable water is not degassed in the first moment already. So, and you can see that we are always already entering, and that is a natural behavior. That's not something that we have found somewhere and it's not true. Natural contents of water has at least a minimum, and I'm speaking even about the minimum, of 11 milligram oxygen, and it contains even always more nitrogen, and this is around between 18 and 20 milligram for 1 liter water. So from the start, you're already putting a lot of air, oxygen and nitrogen into your system. So with all negative effects before you have already, before you actually start, your boiler, your cooling machine, you have already made, a kind of damage into your system. Of course, today, what we also see, that is even also, I would not say in big industrial environments, but a lot of systems today also have a lot of plastic. We see that steel and copper is going down in smaller units. But of course, also the negative point is with all that plastic that we have diffusion. Diffusion is something physical also. It is there, and you cannot erase it. It is a natural effect of plastic and using plastic into a system. So this means also that enterings of air, even when you have used plastic shield tubes, air is always going into a system. This can also be through water makeup from the city, if you fill your system, or you need to create a water reserve for your expansion tanks, like I told just 1 minute ago. Also for all plastic, sealing, everything what's on the system. And of course, what is also important, if you have a vessel, certainly when you work with a static expansion vessel, and this vessel is not good calculated, if we have no water reserve below, then on the top of your system, there will be a lot of sucking air that will come into the system through valves, to radiator valves, to even air separators. So, and that means that you get a really high content of air in your pending system already. If we look actually to, this is a small table, Reflex has also done already a lot of investments, and we are also working together with the University of Dresden. I can speak hours about it. I have also big books and a lot of nice presentations about the testings that we have done with all those universities. And it's also nice to see how some installations or some behaviors are in the system. And here we have done some tests, and this only to show how aggressive, for example, oxygen is, and how fast oxygen can actually attack your system when you start filling, for example, a system. In this case, it was with an absolutely temperature of 10. So we say cold water filling from the city, and of course, a normal atmospheric pressure. And here you can see that I think if you follow the curve, we had a continence in this conditions of 10 milligram for a liter oxygen. But if you can see in the test, also the filling test, you can see that the air is quite fast attacking your system. We are talking about, let's say, from this point to this point, between 8 and 10 minutes. So this is only to show how aggressive oxygen is when you not consider to make your water makeup and to make your system actually air-free. And a big advance, of course, is also, and it's a human advance also, and to be honest, it is a fact that we don't need any chemicals to provide all those things in a closed loop. This is all a natural process. The only consumption that we have is a small amount of electricity, but of course those pumps are good selected, and it's only a little bit of power that we use to run those degas systems. The gas systems that we have today, we have them really small, for really small systems. I'm talking here about systems for 1 cubic, 2 cubic, 3 cubic, and we can of course also provide the standard applications with the control touch. Always the same interface. It's easy for the engineer, it's easy for the installer. It's the same interface again, like the variomods, like the compressor systems, with the same alarms, etc., etc. Those standard systems can also degas already about 200 cubic, what is already a quite, yeah, let's say big system, I think. And also the pressure, we can go up to a system pressure standard around 9 bar. So that means also, for example, buildings that are around 90 or 100 meters in P0. So if we install something like that, of course, we have some cost saving. I know this is an equipment that makes some money. It has a price, this is sure. But of course, we don't need chemicals. You are saving in water treatment. You are saving in water filling because we are controlling everything. It's not by hand done. We are also able, if we have static vessels, this Servitech can also actually maintain the pressure. He can say to a static vessel, hey, your water reserve is not okay. I'm going to give you degassed water so that you are sure that the system is always full of water. Also the highest point, that we don't create negative pressure and that we don't create that air is coming into the system. So that is, like mentioned here, a high performance air separation. Also easy to install. I will come back to this in the next slide. It's only to show that it's not very complex, those systems. They are also, of course, increasing the performance of a cooling and heating system. We also have calculation programs that are tested by external TÜV, so external certification companies, where we calculate actually the behavior and what we are going to do in saving money if we look to consumption of heating and cooling systems. We have the same alarm settings, and of course the system is also running quite smoothly and also quite silent. What is important if we put it, for example, in a hospital or in a hotel, in the boiler room, that the first room in the sleeping room in the building not is hearing that a Servitech is running. So this is also a good advantage. The Servitech construction, I will explain it a little bit. We have an air vent. So here is the air coming out after a degassing cycle. We have, of course, the vacuum meter. The vacuum meter is going, like I have explained, to -1 bar. This is that principle of the Henry law. This is the point where we have the cooking point of water and where we degas the water. We have, of course, here the spray tube. Will be bigger for bigger systems. We have the control panel. We have the water makeup. This is the city line, the water city line, where you can do automatic water makeup. And of course, we also have an option where you can count the water and you can also program this maximum count into the control touch, where you can say, hey, my system may not, for example, automatic filling more than, let's say, 1,000 liter. If he has done this, degassed water, you will get an alarm, and also the water makeup will stop. For the connection, we only have 3 hydraulic connections. This is one back to the system. This is one into the system. And we have, of course, the water makeup. And here we have the pump. And of course, we also use the Bilimo. You can see them here. We are swiping now. This is actually our ball valve that makes sure that in our software and in the gas cycle, we will always maintain the negative pressure because we have to reach that cook point. If we don't reach that cooking point of the water here, we will not degas. It is simple like it is. So this is the technology behind our degassing system. And as you can see, it's all self-adjusting. That means that if we don't reach that good negative point, this valve and our software will always make sure that we get those deep degassings, that we go to the maximum negative vacant point of our running pump. And of course, like I have told you before, we are international protecting this kind of solutions. And of course, Reflex has also made sure that we are patent on all those equipment here for our separation and degassing technology. I will start now also a movie to explain. It goes very quick, the degassing. So we are heating up, the circulation pump is running, we have water, the expansion tank is working, you see the bubbles, they are going from the left to the right, to the plastic heat or cooling floor, and they also go up to radiators or ventilation or whatever. You also see that we have air in the system. So what we are going to do, we will actually start the degasser. The pump is running. We are going to a negative pressure. This is air relieved water. We pump it up to the system. And this is actually very fast, one cycle. And here we have again the pressure. So you can see also that the pump is constantly running in that modus. Here we have negative, but the system pressure is controlled. Of course, if we degas, we make space. If we raise air, we have more need of water. So then this expansion tank can provide, of course, the water in the system. And this is also controlled. If the pressure goes down and we have also less water, we are able to start the degassing system. We get a signal and we will make water city going into the cycle. We degas and we put water city completely degassed into your closed system, so that we can also provide a correct minimum water level for your expansion tank. And then you can also see that, of course, the air in the above pond is going away and it's full of water. And that also means, of course, that your system has actually a perfect heat or cooling transfer of all equipment that you have installed. I know that this movie is always going quite fast, but I can repeat it if somebody would like to see it afterwards. But also in our catalog, I think in the Reflex catalog, we have some principal schemes where you can see what every cycle is doing of the degassing. As you can see here also, we not only do it for small systems, we also make degas systems even with standard. It can also be with Siemens or with other control units, but we also provide them, of course, for big systems. I think this one is built for district heating network. And I think we have a degassing, it's around the degassing around 6 or 7 cubic. So this in an hour that we can degas water on the first stage. And we also have a big line to do automatic water makeup. So we first degas the water, we pump it through the pump, and the pump, sorry, is giving it back to the system. Here we even have two separated systems. This is a line system. This is here a line system. And we have put actuators between. So when this system is running, we will degas and protect this system. When this system is in shut-off modus and we will run this system, this valve will close this one and we will degas the other system. You also can see that we also for the standard reflex degassing systems, we have here a protection sensor switch. That means if the pump starts his cycle and we will not achieve, for example, water in the tube, this protection will get dry, this will get switch off and this switch on, excuse me, and this will switch off the pump. So this is also a dry running protection for the pump in our system. And this is also for the small Servitec degassing systems. This is one that is built now. This is also for district heating. It's only to show this one has to go to France to a big district heating system around 7,000 cubic. This one is designed, I have to do the commissioning in 1 month. And this system can degas around 15 cubic in an hour. And we can do a water makeup around 11 cubic hour. And this system is also running with a standard control box. We don't use Siemens. And the advantages that we also have in this system that we do constantly cycles of degassing. We don't have an interval on the degassing modus. We have 2 lines and the pump is constantly degassing. We have no, I would say it, pause or stop modus. This is special designed to achieve that big volume of water. And it's also showing that, of course, engineering offices show a lot of importance in degassing of closed loops. Otherwise, they would not and never invest in that kind of applications if it would not make sense to do it. So we also see today, even in small, even in big systems, that this kind of technology is getting, of course, more and more important. It's also getting more important by the simple reason that the temperatures in the system are always getting lower and lower. The consumption of systems with 90 degrees, we don't see them not often anymore, except from industry. And industrial systems, we also see a lot of high temperatures. We're also working with temperatures like 200 degrees, 250 degrees. But in normal situations today, you see that water is getting always colder and colder. So to relieve air bubbles and also the nitrogen, we cannot achieve it anymore because the systems are not cooking anymore inside. We have too low temperatures. And that's why a Servitec degas system can provide a really perfect advantage for that kind of solutions. The product range, I think that everybody knows the product names, product range of Reflex, of course. We have the boilers, we have also heat exchangers, we have manifolds, and we have, of course, the degassing systems, we have water treatment, and without chemicals, of course, and we have also the pump systems and compressed systems. We are also there, also Antonio, who is responsible for Portugal, my colleague, Antonio Mirandas, is also available for that kind of thing, but we, of course, can also help you as an installer or a designer. We can help providing solutions and calculations for you. This in power and heating plants, public. We also do automotive factories, industrial plants, of course in hotels and residential. And of course, a big target of us, of Reflex, is that we also are well known in the business of the data centers. We are really working worldwide, and I think this is a beautiful entrance card. And it also shows that we are able to provide those critical systems, to provide them backup in degassing and also in pressure maintenance systems. We also can deliver on skids, small units, where we put everything on, we design everything, we make drawings for the planners, they can implement them in their designs, installers can use those designs. This is easy install, you only have to put the water makeup, this is the connection line for the pressurization unit, and this is for the degassing. We have consumer box, so you only need to connect the power cable, 200 voltage or 400 voltage, and it's done. And that's how we can deliver also on sites for you to make your life easier. And of course, at the end, we also have to help you all together. We have the Reflex Pro. This is a design app also for Windows and Apple, where you can really easy can calculate heating, cooling, solar system, booster pump sets, and where you can receive also then your calculation, and also can see what kind of degasser you need or what kind of pump or static vessel you need. We also have this for the manifolds, the sinus configuration, where you can calculate buffer tanks, manifolds, and design them. You also can receive the drawings in AutoCAD or STEP. This is all provided. We also have, like I have said before, an efficiency calculator, where you can calculate, of course, the system, and where you can see if you could or would use the gas system, what kind approximately money that you could save about consuming of your system. This is also actually to see what is actually a little bit my payback time if I use, for example, a degas system and a pressurization system, of course, in a heating or cooling loop. We also have, everything what is communication. I have not spoken in detail. We can talk a lot about it, maybe in other sessions. But Reflex also have the remote control. So here you can, an installer can see from a distance on his iPhone, on a computer, you can see all the alarms of your equipment that is running. You see all possible errors and so on. So it's only to show that we have a lot of possibilities in Reflex. And of course, on the homepage, you can find all those programs, and you can also find all products, you can find all drawings, you can find manuals in different languages, and so on and so on. So I think that we are at the end. Also, we have the training center. Of course, we are training today. It's not because we have the COVID situation. All people are treating the training center as safe as possible. Everybody is still welcome in Germany to do practice. What I like to do combination of theory and practice. And yeah, these rooms are also available for customers and planners, engineers, and everybody who would like to learn a little bit more about pressurization, work on it, and the gassing system. So this was my presentation. I hope that it was a little bit, I would say, learnful for the people that were listening. And already thank you to enjoy the Reflex presentation. And thank you for your time already.
Thank you, thank you. We are running a short time to the end.
Yeah.
So I will let two people to ask directly questions to you. And I will begin by Carlos Lisboa, please.
Okay, Bart, very interesting presentation like the other one we saw. I would just like to to ask you what, in your opinion, are the applications for the three different technologies that you presented. The first, the static expansion vessels. Second, the reflexomat. And third, the variomat. I believe the variomat with pump control and the reflexomat with compressor, or what in your opinion are the applications for these three different technologies?
You mean to size a building or to use them in a building, you mean?
Yes. When would you recommend to use a static or the other two technologies?
Yeah, I think if we, sometimes it's not so, yeah, this is sometimes difficult. Of course, we are limited. If you calculate an expansion tank, a static expansion tank, on a certain level, of course, when the water volume in the system is too big, or when the heat or cooling power is too high, yeah, then I would say, please disconnect the static and don't calculate that static. An average, I would say, yeah, if we look to system that starts around, yeah, 200 kilowatts, 500 kilowatts, 700 kilowatts, 1 megawatt, it would be not bad to calculate them with a small mini mat or a small compressor or a small pump instead of, for example, a static vessel. But this is, of course, yeah, also a little bit related to what the customer wants, yeah, and what the engineer or the planner has decided to use. But in my average, of course, degassing and pump systems between that, or starting with 200, 400 kilowatts, yeah, I would say go for it. You will already have space saving. You have already the automatic water makeup, and with the pump system, you have already a separated kind of atmospheric degassing. So yeah, in my point of view, this could be a win situation for you as a installer, and also I think at the end, a win situation for the end customer.
And regarding the pump solution, in which you have some degassing, but atmospheric,
yes,
above atmospheric pressure.
Yeah.
I wonder, is this enough? Shouldn't we always have under atmospheric pressure degassing using Servitec?
Yeah, of course, but it also depends. I know it's like the same if you buy a car with some options. Some options are important, but not everyone buy them. And this is a little bit the same situation here. We can speak about it. We can provide those systems, but at the end, it's always the customer that has to decide. Okay, is it important for me or not? Of course, it's important. And of course, with the degassing system, you also have the possibility to do the nitrogen. It's not only the gas, the air, it's also the nitrogen. And this is something that you can, of course, not do with the pump system. And of course, at the end, it will be always a win-win situation, especially for the client and also for the energy consumption and for your equipment. I think you will achieve better result in, for example, defaults and pumps. That is quite critical. So at the end, it will be a saving cost. If you look to time and install, it will be at the end. It will be a saving cost anyway. This is my point of view, of course.
Okay, we have another question from João Silva. Please, João Silva.
Hello.
Yes, hello.
Yes,
one small question. Imagine you have a small apartment, 80, maybe 100 square meter, where the kitchen, the boiler is located in the kitchen cabinet, and you have a condensing boiler because you have an underfloor heating system with plastic pipes. And of course, you have oxygen migration into the system. And with aluminum condensing boilers, oxygen is...
This is, yeah, then we are talking.
Yeah, it's poison for the boilers. So what's your advice so we can avoid the corrosion of the boiler body due to the oxygen migration from the pipes?
This is, yeah.
Is the expansion vessel enough, or should we use some active protection?
Yeah, of course. First of all, what is the most important to start with is the expansion tank. I see that those boilers often have their own small
yes.
tank.
Usually opinion, 4 to 6 liters expansion.
Yeah. In my opinion, this is okay because those apartments have not a lot of water content. But of course, the visible aspect, those small expansion tanks will maybe not work as good as we have already an extra or small expansion extra tank. I speak about 10 liter, 8 liter or 12 liter above, where you can put, of course, a little bit already more water reserve. The problem is also that in those boiler rooms, those in the small boilers, the small expansion tanks, it's difficult to see when they are broken. And if the P0 is already too high, yeah, end of story.
Okay. Sometimes there are problems with the newly installed boilers after 2 months of installation. So the expansion vessels should not be broken so soon.
Yeah. And you can protect it the installer can protect it to maybe already use a small external expansion tank.
Okay.
Yeah. Of course, you also need space. In the apartments today,
yeah.
It's also a question of space. Do we have enough space to put all those technical equipment above the normal equipment? This is
okay. But in your opinion, an external better dimension expansion vessel should be enough, no?
Yeah. Because you can also you are also better to arrange the P0 of that small vessel.
Yeah.
And if, for example, your client is degassing something, or there is some air diffusion, you always will have a kind of better, like I told, water reserve.
Yeah.
And this is really important in a system.
Bart, Servitec Mini.
Yes, that can be also a solution to degas also. But of course, yeah, the Servitec Mini, I don't know. That's a new product that Reflex has designed for small apartments. It cannot do water makeup, but it can degas, of course, the system.
Okay, I'll look for it. Servitec Mini.
Yeah, you have to ask maybe Antonio for further details about technical sheet and data sheet and price.
I'll look for it. Thank you very much for the presentation and for your answers. Thank you.
No problem.
So I believe we have no more questions and we have no more time also. Okay. So Bart, thank you very much for your excellent presentation and for great products that we have all learned about. And I hope everybody learned something today. Thank you very much, Bart.
Bye.
Thank you, Bart. Bye.
Bye.
See you next.
Thank you.